I'm not sure what you meant by that question.
Oh, it wasn't a question. Alexa, say hello.
Hello.
All right. So you guys about ready to get started? Yeah? Everybody awake? Everybody's... All right, so Team Captain America? Team Iron Man? Wow. All right, so Voice of the Enterprise. You guys are here for this, right? All right, cool. So to start off, my name is Bill Klos. We'll get to a little bit of introduction in a bit, but I want to start off with some geek cred. Hopefully it's geek cred, or it's just nerd cred, or it's just sad, depending upon your point of view. So I took a vacation this last year in August up in Quebec, and we were doing the cycling, riding around, and eating chocolate and drinking wine, and we'd go to bed and breakfast, and we'd have 3 or 4 star meals, and the next day we'd ride some more, eat some more chocolate, drink some more wine. It was a great trip, but here's the highlight. We're riding one day, and all of a sudden, I go, oh my God, there's the Google car. And waving like an idiot, like this, and the Google guy goes, 4 months later, I kept looking. I knew exactly where we were when I saw the Google car. 4 months later, I took this, went out and looked, and it's like, all right, it showed up finally, because for the longest time, it wasn't out there. I figured anytime an idiot does this, maybe they're just blocking them out. But it actually showed up. And I showed it to everybody, and my daughter's like, yeah, Dad, we're on the Google car too. It's like, what? Yeah, our house over here at OSU, they have a big sign in front of their house that says, fathers hide your daughters, or some crap like that. I can't exactly remember what it was, but it's out there like that. It's like, well, if they show that, then obviously they're going to show me like this. All right, so geek, nerd, sad, whatever you guys want to say with that. All right, so I'm Bill Klos, live here locally in Columbus, senior architect for Centric Consulting. I specialize mainly in cloud stuff, mobility, and alternative technologies, and sometimes that still includes AS400 because I refuse to take it off my resume because I know that I just turned 50, so when I turn 55, 60 and I'm unemployable anymore, I'll still be able to get work doing old RPG 400 code for companies that have not quite moved on. So what we want to talk about today, I want to talk to you guys about voice, and we'll talk about some of the promise that we've seen in some of the movies and some of the books that we've seen and some of the books that we've read, and then what we actually have available to us today and kind of how you can leverage it. The promise is kind of the Star Trek thing, right? You're walking down the decks of the ship, and you just shout out whatever you want, and the computer just reacts to what you want to do and handles your request. Same thing with 2001: Space Odyssey. Interstellar's got some of that too. And if you guys remember Mother from Alien, same kind of deal. It's all this ubiquitous, permeated ability just to talk like we're doing now and just have something react to your voice. And if you guys are fans of The Canvas, which is a book, or The Beam, a book series that's out there, when you say Canvas, wherever you are, on the streets, in your apartment, wherever it happens to be, you have something to respond to you. Now, what I'm not talking about is AI. Okay, when we go through and talk about today, is completely, you're going to see it's like there's no AI with this at all. There's no intelligence aside from what you put into your code. It's essentially just a voice response type thing. So things I'm talking about, being able to do quick status updates, asking me, hey, what's the status of my overnight jobs? What's the story with the dog? That's actually a use case that I've got with a client of mine. Did mom take her medicine today? Those types of things. Those are the things I want to know. And just if I'm home alone, or I just don't want to have to hunt somebody down that knows the answer to this, if I can just ask the internet essentially and get that answer, that would be great. Executing actions. So if I want to actually instantiate something, so I start a new job, ramp up some new VMs, do something for me, get my, call Uber, those types of things. That's what I want. Blow up the ship, which we'll actually do sometime today. Let's see. So what's so good about it? Less friction, more natural. You guys use it now. Siri? Anybody? Cortana? Google Now? All right. Amazon? Just a few? Okay. It's when it's good, it works great. When it does exactly what you want it to do, when you want to do it, no matter how you say it, it's perfect. It's awesome. If it's pervasive and ubiquitous, I don't have to go into a special room, or I don't have to push a button and hold something up to my hand or to my face. That's great. If it can be conversational, where we can just kind of talk, and I don't have to keep asking it the same thing over and over and over again in order to get the thing to respond to me. And it's free. I can do other things. I can just say, hey, we'll turn this off real quick so she doesn't start going nuts on me. Hey, Alexa, what's the weather outside type thing? And then have it just do it while I'm continuing to do my work. When it's bad, when it doesn't work very well, it actually takes your focus away from what you're doing and you have to focus on that voice situation. It also can add to the environmental chaos. I talked to somebody about doing these things. They had a call center situation where they've got hundreds of people out in an open area. If they're all doing voice of some sort, then you're going to have problems. And then also the potential for global thermonuclear war. If you just say, hey, launch the missiles, and it just does, then that's an issue. All right, so the candidates, and I started dealing with this about a year ago when the Echo finally became public, and they published their Alexis Skill Kit. Some of the things I'd always wanted to do Siri, since I use Apple products. Siri would be perfect if they would open up the API or the SDK so I could get in there and actually extend it. That would be great. The problem is I don't always have my phone, on me or with me. I don't want to have to reach over and punch a button. Even if it's plugged in, sometimes it doesn't always pick up my voice. And I may be in another room from where my phone is, those types of things. So I need something a little bit more open air. Google Now is cool on the Apple stuff, but it's not built in like it would be on Android phones. Cortana, same situation. So the non-mobile piece is the Amazon Echo. So that's what I ended up picking because it had some opportunities for me that I could play with. So on the plus side, it was cheap. It's relatively cheap. We have here today the small one, the new Dot. It's a little bit cheaper than the tall one. Less speakers, same kind of capabilities, but it's not as much tuned towards playing music, that type of thing. There's an API and there's an SDK for it, so I can actually extend it and do things with it. And it's easy for me to develop too. When you guys get out of here today, hopefully you'll look at it and go, holy crap, that's super simple. If that guy can do it, I could do it. And it's pretty much the case. I mean, if I can do it, Prague, you could do it. You can host it anywhere you've got HTTPS. Voice recognition is actually pretty good, and you can actually extend it to make it do better things, some foreign language stuff, some accents and intonation type things, word choice, those types of things are all in your control. It can own a room. So you walk into a room, you can just basically start talking to it, and it starts doing things for you. And it's being extended all the time. So like Uber, you can order Uber cars now with it, Domino's pizzas with it, those types of things as well. So it's not just weather. And it's got good support and good community. Now the minus is, though, it's voice recognition, and I was talking about this morning a little bit, but it's not your voice. So if you came to my house and said, hey, Alexa, order some underwear, it would order underwear if you knew my passcode. But it won't distinguish between you asking to order underwear and me asking to order underwear. It's just going to do it. And if you know the passcode, it's done. It requires an internet connection. The last time I talked about it, we had to, and actually we're doing that today as well. We don't have internet, so I'm having to go out through my phone. It still works, it's just a little bit slower to do it that way. Testing can be wonky. So if you're kind of a hack and test kind of guy like me, sometimes it's like, oh, let's see if this works. Okay, it kind of works, let's see if this works. Okay, it really works. So you run your test, that's great on the screen, nobody cares. But when you're testing this in that same kind of fashion, hey Alexa, launch the thermonuclear weapons. Crap. Hey Alexa, launch the thermonuclear weapons. Okay, so if you have to keep doing that over and over and over again, everybody's going to get mad at you because you're saying this over and over and over again. So testing becomes an issue with these things. You can't take it with you, aside from like I have it here. Now they have smaller ones, it's easier to do so, but it's still one of those things you have to have power wherever you go and an internet connection. It's not as feature-rich as the iPhone, but it's getting there. That's more of a cloud thing, and as they add features and capabilities to it, it's becoming pretty good. It cannot initiate an interaction with you, which is fine because nobody else can either, but that's going to be the next step where I have to basically ask for, give it a stimulus and it gives me a response. What I would like for eventually is for it to give me a stimulus and have me respond to it. Hey, Bill, all your databases are down. Oh, crap. Spin them up again. That type of thing. And using your services is a little bit less natural than native service, and we'll talk about that. So general usage. For those of you who don't have one, essentially what we're talking about here, let me step back a bit. Who are my back-end developers? Anybody? All right, everybody has front-end development? Okay, mobile? Web? All right, this is just basically if you had a third arm, mobile, web, voice. I mean, that's all we're talking about here is just a front end to this. So you still have to write a back end. The back end does its normal logic that it normally does. You just have to have a few things put in place in order to be able to take that voice that comes in and then do a response back to it. So in the grand scheme of things, in this particular application, it's just one other piece in the UI portions of whatever you're building. Now, the general usage, for those of you that have one, you know this. If it's something that's built into Alexa, you just say, Alexa, do bleh, and it comes back with a response. In your situation, when you write your own applications, it's Alexa, tell my application to do bleh type thing, or do whatever, and it comes back with the results that you have back. So when I say it's a little bit less natural to deal with your stuff than Alexa native things, that's what I mean. There's that little extra step that you have in there. So in this case, Alexa, turn on the lights downstairs. It comes back and says the lights are now on. Whereas in my particular thing, it's Alexa, tell DevOps to spin up another process, and it comes back and tells me there are now 6 order processors running. So that's the extra step that you have. So it's not a big deal, but it's just something to remember that it's something else you have to do. One of the first questions that everybody always asks me is, can I change the name? You have 3 names. I need to update this. You have Alexa, which is the default. You can call it Amazon, or you can call it Echo. Hopefully someday they'll let it be out to whatever you want to call it, because kids or people with kids named Alexa, while it's fun to begin with, it gets sick around the house pretty quickly after that. And then you address your skill, the whole ask my application to do this, tell my application to do this, open my application, do this, launch it, whatever. All those are syntactically different, but they're all effectively the same. So it just comes down to what's more natural for the particular command you're trying to issue. So when I'm doing get type stuff from web services, I say ask, because it's going to give me information. If I want it to do something for me, like a post or put or delete or whatever, I say tell, or whatever would be a good verb thing for it to do that, and it goes and figures it out. That's just, but you can say tell to get information. Just tell Alexa or tell my application to get me the results I want. It'll do it. It's just more of a natural language type thing. All right, let's see. Let's see if we can get this thing to work today. Alexa, ask do forward, what is the current status of the database?
All database servers are currently operating normally.
All right, now it took a couple seconds for the first one to go through, because I'll tell you why in a little bit, because I'm running on Heroku and I'm running on the cheap free version that shuts down every 10 hours or 2 hours. But essentially, I just asked do forward to do whatever I wanted to do, and it comes back with the answer. So Alexa, ask do forward how many documents need to be processed. Make sure you hear me. Alexa, ask do forward how many documents need to be processed.
There are 44 documents that are scheduled to be redetermined.
Alexa, tell do forward to kick off a process job.
This will be an unscheduled execution of this job, and as such, it will run immediately. Is this okay?
Yes. 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 Confirmed. Action. Yes. Do it.
There was a problem communicating with the requested skill.
All right. Alexa, tell do forward to kick off a process job.
There was a problem communicating with the requested skill.
It's not going to cooperate at the moment. And it could be a situation where Heroku decided, hey, you're cut off because you're not paying us anymore. So essentially, and we'll talk about some of the things we just went down and did, because we did essentially a conversation with this. The kicker is there would be 44 records, and then you tell it to kick off a job, and it comes back, you ask it again, there's 0 records. That's the goal for it. It usually works. So let's talk about how to develop for it and what you'll need. You'll need an AWS account, a developer account with them, free, not a big deal. There's the URL for it up there. You'll need an Amazon Echo of some sort. You can get the big one, you can get the small one, doesn't really matter. You can do some stuff without it. So I'll show you a couple of slides that you have, or a couple of screens where you can actually programmatically go in there and test your APIs and so forth with the voice you send and see what the response is going to be. But at some point, you're going to want to be able to, especially if you're going to try to ship something or put something in production, you're going to need to be able to test it with somebody who's actually speaking voice. An intents file, which we'll talk about, an utterances file, which is essentially example phrases for it to go against. Your language of choice, whatever you want. There is no restriction on whatever language you use if you have your own server, for example. If you want to use some of their stuff, like their Amazon AWS Lambda, I think it's Java, JavaScript, and one other one I don't recall at the moment. But they're adding more languages to that. But for the most part, you can use whatever language you want. I use Go. And then a server with HTTPS. Oh, here it is. So Java, Node, and Python, you can use Amazon Lambda, and then more languages will be added at some point, but you still need to have HTTPS endpoint to point it to. So the Alexis Skill Kit, this is essentially what they have, and when you're going to see it, it's not a thing. It's what it is a framework, or basically a standard of object definitions that you have. So that's where you can do whatever language you want. It's like here's the JSON that we expect that goes into the echo, and here's the JSON that comes back from the response. So from that perspective, as long as you can build objects in whatever language you want to use, it does it. So when you log in, the first thing you'll see is you'll create an Alexis Skills Kit. And the top one, or whichever one, you can basically there it is sitting out there. It's like, just pick whatever one you want and edit it. And then you specify, it gives you a key, an ID key for the actual application, which you'll use to make sure that you actually have the right request coming into your application. So that way, if it doesn't match this, then somebody else is trying to instantiate your stuff. You'll name it. You'll give it an invocation name, in which case I had to do forward for the name of my application. So when you say, Alexa, tell do forward to do this, that's the name there. And then what you're going to use, either your own server or the Amazon Lambda stuff. This page is essentially the top. What ends up happening is when you talk to it and you give it commands, it parses it out and it looks for key phrases. So I usually break my stuff into like actions or objects and verbs and that type of thing. So I've got a object and a phrase and an action in this case. So if I say, tell me, which is nothing, about the database, my object, and how many jobs are left, that would be kind of my action or verb, then I can parse that out, and then my code would then look for those keywords where it puts in those slots. And these are the slots that you have up here, action, phrase, and object. Based upon this object and this action, do this action on the back end, and then this is the response that goes back, based upon what the outcome becomes to be. Then on the custom slot types, if you have dates or whatever, things that you want to, they're always going to be the same, like I have some times up here for last month, this month, last quarter, this quarter. You can put those in there so it doesn't have to decipher those. It's always looking for these types of things, and when it sees them, it puts them into the appropriate slot. It kind of just helps your programming on the back end. And then finally on the bottom here, which hopefully you can see, is a picture of a sample utterance file. So it's ask, do forward, what is the current, and status is my action of which is just extra stuff, and then database is object. So when you get your code, the only thing it sees, it'll see this ask, do forward piece. It'll see this whatever's in the status or action here, and whatever's in the databases or whatever's in the object, which in this case would be databases. You don't have to put in something for every single thing that you do. So if I wanted to check the status of the web servers, in theory I could do it with just having this line in here about databases where it would put in web servers instead of databases. Now what you typically do is you give it a sampling of multiple things, which we'll talk about a little bit later about how you specify what you're asking for and what you're expecting. But the whole goal is not to make you type in every single thing that could possibly happen and have the echo actually try to figure it out. So all that is just JSON, and that's what the intents file looks like. The utterances file looks like this. And I have query do forward, is what in this particular case. I can segment it off, and I'll show you some really cool tricks we can do with that in a little bit. And then some of my utterances as far as what I should be actually asking for, some of the sample requests. All right, then finally, I specify this is my development endpoint as a subdomain that's got a wildcard certificate, so that way I can test with it. In order to be able to actually put it in production, you've got to have a legit HTTPS certificate and all that kind of good stuff. I'm lazy, which is why I'm using Heroku. I'm also cheap, which is why I'm using Heroku. In this case, because I didn't want to stand up a full-blown server for this type of stuff until somebody pays me to actually do it. Right, Prague? That's right. All right. And then you turn it on. And then here's some of the things we talked about, or I mentioned as far as being able to test without having a device. If you specify, in this case, the voice simulator, you can specify SSML, which is essentially its own speaking type markup language, where you can add inflections and say use this dictionary versus this other dictionary. Here, bass and bass are the same type of thing, but then you can actually distinguish between them. And it allows you to set that up here. And then, let's see, the next one. Oh, here's actually a sample of an interaction. When I put in my example utterance at the top, what is the current status of the database server? Here's what the actual request looks like. And then here's what the response comes back from my API. So you can do some of this stuff without having a device, but it's relatively limited. I mean, you can write all your APIs, you can get all you can do all your coding, but until you start talking with it, you're not going to understand how it actually deals with language and with especially people like me that kind of stumble over words and that type of thing. If it works with me, then it's going to work with just about anybody. All right, so considerations. Designing your input options. How casual, how formal. This is where you have the ability to be all bombastic about it. It's like, Alexa, please give me the status of all of these database servers that are currently operating within known parameters in nominal fashion. It's like, all right, whatever. Alexa, what's the deal with the databases? So you kind of determine what you want to do as far as what kind of voice you want to give your application. Just like you would be from a visual standpoint is what you're looking for. The same thing from an audio standpoint as well. Who is your audience? How quick are they going to be asking for information? How much time are they going to have for the feedback? And what's the typical conversation going to be with them like? Because you want it to be natural, not to be some sort of weird thing. So determine how many different ways can you say it as well. It's let's see. I need a volunteer to converse with me. Really? Okay. Hey, what's your name? Marche, what's up? Marche, how you doing?
All right.
Hello, Marche, how you doing? How's it going, Marche? So there's all different ways that we can sit there. I'm sorry, I was kind of leading you a little bit. But there's all sorts of different ways that I can talk to you every day. If I say the same thing to you every single day, and you give me the same exact response every single day, then it becomes more mechanical type thing. So one of the things you'll start figuring out is, all right, how many types of different questions can I ask the same thing? I can take my little slots of variables in here is where I'm asking for the status of the database, and I can ask it 10 different ways. Do I want to account for all those? Now the response comes back, all right, Alexa, how many databases are up? 6. Alexa, how many databases are currently running? 6. I mean, do you want to dress that up even more? There are currently 6 databases running, all of which are running, normally. So you can have the formal, you can have the informal, and go on from there. That's something you'll have to decide how you want to do. So responses are the same way. Read-only is very safe. It's easy to do things read-only. Just give me status, give me status, give me status. So think an executive in their office. They just want to come in the morning and say, all right, how much sales did we have yesterday? How many sales are we up to this month? What's my current status to plan? All that kind of good stuff. Versus, something that's more right, where it's like, Alexa, fire everybody in the accounting staff. I mean, those types of things require a little bit more effort and security to put over. So reading is easy. Having it do things are a little bit more difficult. Especially if you misstate, oh, I didn't mean accounting, I meant HR. Crap. Sorry, guys. Transaction size. Short and to the point on both sides. You've got about 10 seconds before Alexa kind of gives up and says, yeah, I ain't happening. Those types of things. And then testing, as we discussed, is kind of an issue too, because you've got to, how do you test all those inflections? How do you test all those different phrases? I have a randomizer on my return when it comes back. So if I have 5 different responses for the same question, it's making sure that randomly gives me back the ones that I want to get, and I see all of them hopefully at some point in time. Setting up your app. Relatively quick. It's for Amazon certification and publishing, you have to verify the request was sent by Alexa. So you'll get some keys from that. Make sure the signature of the request, the timestamp of the request. You don't want to be answering something that was sent an hour and a half ago. And we don't need these for testing, though. We can just throw these out there and just start testing your application pretty much right away. You verify the application ID matches the one it gave to you, so therefore you're not trying to answer questions for some other app. All right, coding the app. Stimulus response. This is where it gets to be simple. Essentially, this is what it looks like. So the echo captures my request when I say it, and it formulates the request packet, which basically puts it into the format with all the different the variables in the slots, that type of thing. and then it routes the request to whatever endpoint it's got, what I gave to it, so basically my API. From there, I process the request. This is my code now. I formulate whatever the response is going to be, and then I speak it. I basically give it a string back, and it speaks it. So the response that comes back to the echo is just a string. It just reads whatever you put out there. You just have to figure out what you want to plug in as far as variables with and how you want to put it together, that type of thing. All that within about 10 seconds. The other thing it also does, and I don't know anybody that uses this, and maybe for you guys that run echoes or use echoes, maybe you use it, but in your application, it's kind of like the card app in Google Now, where you ask something and it comes up with a card of like, here's the weather for the day, and it's like, great, thanks for telling me. And it also says, oh, I'm showing you too. See, isn't it cool? It does the same thing. It sends that packet. It'll send that packet along there with you if you want to code it up to, put something together with clouds and rain and forecasts and that kind of stuff. You can do that too, but it like puts it off into another portion of its app that I never look at. So by default, what I use it for is more of debugging. So it just basically sends back, Alexa heard this. Alexa, what is the weather like in Sandusky, Ohio on Friday? I was at Code Mash. And then it'll ask you, is that what you wanted? So you can use it for debugging purposes of it, but for the most part, I don't play with the response cards at all. All right, general architecture. This is the stuff I like. All right, so you got your Echo, and what I'm doing on Heroku is I'm kind of cheating. My API is sitting somewhere that's not on an HTTPS server at DigitalOcean, just because I don't need it. But I need to have HTTPS for it to talk to, so I just put up a little pass-through at Heroku that stands up, and all it is an application that it receives in the voice, and it passes it through to my API. So in theory, I could have multiple applications go through the same one and not have to worry about it and have just multiple applications on the back end that respond back to it. But that's all I have right now is just a pass-through for my HTTPS purposes. My application actually does cool stuff with it, grabs from the data, and then sends it back. Not a lot of work. And the pass-through call looks something like this. Hey, I actually remembered to wipe out my API key. Nice. So it's just basically, here it is, looks at it, okay, it's cool, and sends it on through. Now, here's where I talked about basically what you're needing to do for whatever language you want to use is you take the object definitions that they give you, because basically it's here it is, here's the JSON structures that we expect. So when Alexa says, here's what I'm going to give you, here's all the different structures, and you just code them up to build whatever framework you want. And this is just an example of their actual request session where it comes in as strings. I've got attributes that basically specify some of my variables in there, those types of things, and it's, like I said, once you get that down, then when it comes in, it just fills all that stuff in, and you're good to go, just like a regular application. And the pass-through response, as you can tell, it is, let's see if I've got one up here. I just take whatever response I have, and I just marshal into JSON and go through. What ends up being is just strings. Like I said, it's just strings. There's no weird stuff that it does with numbers or other types of objects. It's just strings. And the response body looks like this. Again, just some strings and some other things to go around it. We'll talk about some of the should end session, for example, in just a second. But for the most part, it's relatively painless and simple. Intents and utterances we've already talked about. These are your object slots or your variable slots. And then the phrases that you're going to use. Now, here's where you start breaking it down. Now, this is bad code. You would not do it this way in real life. This is done partly because I'm lazy and partly just because it's easier to show. I've since then started changing how I do things with this, so I don't have these big monster case statements all the time. But essentially what it is you've got your case where it says ask do forward. So if ask do forward comes through, then look for database or databases. And then in that case, if it's database or databases, and I see also a status or running or active, then I go out and grab the number of databases that I have. And then if I've got an error, I have an appropriate error message and so forth. But if I'm asking for documents, objects and records and articles, those type of things, then I do something different. So it comes down to here's where you have to figure out, based upon the vocabulary I want to use, what are the different things that I want my application to do and respond back with. Another good example is we have, sometimes you have a lot of things that mean the same thing. So yes, affirmative, positive, hunky-dory, go for it, rockin'. All of those mean yes in some shape, form, or fashion. So I can actually specify those in, so when I'm doing a conversation and I say my respond yes, do forward is yep, yes, yeah, affirmative, yes ma'am. And then for no, no, nope, negative. So no matter what you code, if you're asking for questions and you always say look for a response no, if it's one of these, it'll match it up. If it's yes, if it's one of those, it'll match it up. So you don't have to put that in your code. You actually do some tricks with your intents file to basically say these all mean essentially the same thing. And an example of that would be here. So if any of those come through, no ma'am, nope, nah, those types of things, it'll come through and hit the same code. All right, conversations. This is where it gets to be cool. That all stuff is lame compared to what this stuff is. This is the good part. So I'm glad you stuck around for it. So conversations. Conversations is, what I hate doing is, Alexa, what's the story here? Alexa, what's the story there? Alexa, tell me the story about this. So I keep having to go Alexa, 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 just like you do with Siri, 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 Siri. What I want to be able to do is basically talk to it in a conversational way. So, but there's a couple of good reasons or a couple of good things about conversations. The first one is disambiguation. And if you guys are Wikipedia fans, you know what this means. We did an event every year and for my company. And last year we were playing with the check-in, trying to do some sort of check-in module when people come into the show. And they say essentially, all right, Parag shows up. I pick on Parag because I work with Parag. He shows up and, tell Camp.io to check in Parag. Okay, that's great. But what if Parag's, we're not the only Parag. There's other Parags out there, right? So there's other Parags out there. So it's which one do you want to check in? So in this case, I use Bill because Bill's relatively common for old people like me. Tell Camp.io to check in Bill. It's like, all right, you mean Bill Klos or Bill Chamberlain? Bill Chamberlain, or the second one, or something like that. And it's like, okay, now Bill Chamberlain's checked in. The problem we found was, and we tried to do, and we actually did it this way too, is I could say, Alexa, check in Bill Chamberlain. Works for the most part. You get a first name, you get a last name, you throw in both, it figures out, tries to put them together, looks it up in the database, sees if they find a match, and comes back. Okay? If you don't get the Chamberlain right, if it hears something different, especially in noisy environments, then it can be a little bit wonky, and you get like either a lot of false negatives. I don't see a Bill Chamberlain in here. So if you ask for Bill, have it get that small set, ask for Chamberlain, and have it match it up, then you're pretty much good to go. So it's just a way to kind of help ease that conversation a little bit if there's more than one. If there's not more than one, then it's easy. Bill's checked in because there's only one that's out there. Prompting the user. Let's see. Alexa, ask do forward.
You can check system status, gate metrics, or run a job. Which would you like to do?
So from that point, I don't know what I can do, so I say, hey, just instantiate my application, and it comes back with a kind of a welcome message or a help message. So it's just like typing something on the command line -H. Here's a list of things you can do. In this case, what I would normally do then is leave that conversation open, so then I can say run a job, and she would say which job do you want to run, and I want to run this job. So you can definitely do it in a long string. We'll talk about that when we blow up our Starship. But you can also walk the user through these types of things if you do a conversational mode. The tell me more, it's Alexa, ask what's the current state of the database. All database servers are operating normally. Great. What about memory usage? Memory usage is 11%. Awesome. How many documents need to be redetermined? I currently have 177. So it's, instead of me just saying Alexa this, Alexa that, Alexa this other thing, it's basically a conversation I can keep it going as long as I want. And as long as I'm getting anything else, getting good information, I just keep going. And when I'm done, I say, in this case, do you want me to clear them out? And it runs the job. I say, please. And she says, done. Okay, we're out. So navigating a process. This is the other thing, and we kind of alluded to it. Star Trek fans? Star Wars fans? Ugh. All right. I'm trying to see if there's a correlation between Star Wars fans and Captain America or Iron Man, or if there's any kind of crossover there. All right, so some things are very complicated to do. And in this case, if I wanted to initiate the self-destruct sequence on a starship, it should be harder than it usually is in Star Trek, right? So if I want to say this, I was like, all right, Alexa. Okay, good, it's off. Initiate self-destruct sequence code 1-1A, set for 5 minutes. I want it to be a silent countdown except for the ticking clock sound that mysteriously plays a ship-wide over the speakers. Thanks. So just like in Alien, the original Alien, when Ripley says, all right, we're going to self-destruct the ship, and it's like going on. And the alien knew what was happening. That's why it hid in the escape pod. So that's why you would have a silent one, right? But that tick, 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 what is that tick? So this is great. I wouldn't want to code for it, though. All right, because it becomes crossing a big blob. And if I transpose a couple of the words or misstate something in there or kind of garble something, then it completely doesn't happen. And I need to blow up the ship now. All right, so let's see if we can do this. Alexa, tell do forward to initiate a self-destruct process.
You can check system status, gate
I said the wrong
metrics,
word.
or run a job. Which would you like to do?
Alexa, tell do forward to initiate self-destruct sequence.
Destruct sequence activated. Please provide authorization code.
Alpha, alpha, alpha.
Authorization accepted. Please confirm your decision.
Do it.
Confirmed. Self-destruct sequence in process. Sorry you're having a bad day.
So if you notice in that little conversation we had, I only said Alexa once, and then everything else was just a back and forth type thing. So what we essentially have then is a situation where I've got a new request coming through, and my application can see this stuff because it comes across as part of the request packet. I've got a new request. I do the stuff, so I want a job to run, and my job to run is self-destruct. And the job to run I just made up. I mean, it's not like it has a concept of jobs. I just gave it the concept of jobs. It's like, all right, here's these things that you know how to do. And this one, I want to run the self-destruct job. So it says, here's your output speech. Please provide authorization code, and then should end session false. So when you have that should end session false, it keeps it open. Now, it only keeps it open for X number of seconds, and it's kind of configurable. Actually, not kind of configurable. It is configurable. So you can say keep it open for 5 seconds, keep it open for 20 seconds, whatever you want. Eventually, it'll time out if you don't say anything. But it also has the ability to prompt in there. It's like, hey, we're waiting. Come on. It'll do that, too. So we essentially keep the session open. So the next thing that comes through is it's no longer a new conversation. So when this comes through, I see that it's false. So my program can say, all right, this is an existing conversation. I need to link that up with what was going on before. And here's my attribute. The job to run was self-destruct. So basically, I give it, when it talks to me the first time, I give it, it's like, all right, here's the stuff. Here's a little tag. Keep it. So it's back, you remember the days back when HTML, you had to put hidden form fields on there to do state in between pages? No, because you guys are all like really young. Okay, yeah, you used to have to do that kind of crap. So you basically, what you're doing is you're giving her a parm. She takes it back and says, all right, do whatever, and it comes back and gives you that same parm. So I'm keeping looking for that parm. And when it comes across, my session attribute now is I've authorized it because I went ahead and I said yes, confirm, do it, whatever. And then I'm still doing the self-destruct job. Now it's accepted my authorization. Please confirm your decision. And it's still keeping the session open. And again, it's still not new, still same conversation. Authorized true, job to run self-destruct. And now my end session is true. So now it's done. It's going on about its merry way, and it's doing all sorts of cool stuff. All right, so what about security? So yeah, you're going to blow up a ship. You're going to need to have a little bit of security on it, probably more than the alpha, alpha, alpha. Let's see. Alexa, tell do forward to initiate self-destruct sequence.
Destruct sequence activated. Please provide authorization code.
Jedi, Jedi, Jedi.
If you're a Jedi, why don't you try using the Force?
So in my little thing here, it's just a simple thing that if I request self-destruct sequence, tell me your authorization code. If I'm the captain, great, I can do that. So if I, Alexa, tell do forward, cancel. Alexa, tell do forward to initiate self-destruct sequence.
Destruct sequence activated. Please provide authorization code.
Vulcan, Vulcan, Vulcan.
You're not the captain in this timeline, Spock.
So, and that's kind of the extent of my security that I have at the moment because it's not a voice print. It's not a voice activation. It doesn't know my voice versus Spock's voice versus Luke Skywalker's voice. It just knows that here's the words coming through and it processes the words. So that's something you have to put in whenever you're having to do something, especially on a put, post, or delete type operation. That's what you're going to have to do, as opposed to just all the get stuff is relatively easy. Even though if you're talking about, hey, tell me what Parag's salary is, you probably want to do something on that one as well. So understanding. What did I say? So when I talked about how Bill Klos, Bill Chamberlain, kind of that whole disambiguation thing, we have a little problem. And sometimes what Alexa hears, my name's Klos, which I've seen so many different ways. Sometimes it comes through his class, and this is I'm just talking like junk mail now. I get it all sorts of weird, wacky ways. But Alexa takes the same types of things, depending upon how you say it. Like if you were to see my name and you were to register me here at this event, you may think it's Klaus or Klaus or something like that, in which case Alexa may put something different in there and it's not going to actuate on your application. So if you use something like a Metaphone or a SoundX or some of the NISIS stuff, you can actually kind of break that down into its formulaic way of taking words and breaking them down that are something easier to digest and hopefully deal with. The problem is it doesn't always work out for you as well either. So like for example, on Metaphone, my name breaks down to WLMKLS. Incidentally, we have a person in our organization's last name is Galuzzo, same damn thing. So G and an L and a Z somehow ends up being K, L, and S in there. So from that perspective, if I'm looking up based upon that solely, then I can't do that. So you're having to deal with things that are somewhat inexact at this point. If I use SoundX, then my name breaks down such, and then if I use the NISIS stuff, it breaks down in a different way. So if you consider William Klos, these are all the different ways it could possibly break down based upon some of the things I've seen in junk mail for how my name is how they've actually spelled it. So as you can see, it's not going to be an exact science as far as looking things up. So what we end up doing is, there's lots of different things we can do. One of the things we try to help make it a little bit different, and these are 1, 2, 3, 4, 5, 6, 7 different names that we have within the company. If you notice, they are a combination of 1 syllable, 2 syllable, 3 syllable, multi-syllable, just like lots of long different names. The more you throw at Alexa, the better she gets as far as figuring things out. So this actually was able to capture, I think, 250 to 300 of the names that we had based upon the sampling that we had of 6 up here. So when I told you before about when we had the database slot and you could put in like web server in there and have it work, this is what that key is. Because if I have 800 people in my company, then it's going to be a situation if I have to always keep this thing up to date with 800 people. So in this case, what we would do is if the first name is not blank, last name's not blank, then I can do these different things. And if I don't put anything in there at all, then it kicks it back. And then I use the phonetics then to look at the name. So what you end up having to do is, like in William Klos, Eric Galuzzo, not only do you store my name, is you store whatever SoundX you're using or algorithm you're using to break that name down, you store that too, and that becomes one of your keys. So you look up the SoundX names as opposed to my legit name. Or you could look up my legit name. If you can't find it, then look up the SoundX name to see if you find it from that perspective. And if I go by Bill, you're screwed because they're all keyed to William. So nicknames, I mean, it's the whole kind of thing is Bill, William, Robert, Bob. It's going to have a problem with all those unless you put those in there. Exactness. One thing to not worry about is try not to be exact. And I tell this to big data people all the time, is they're always looking to foot and tie every single transaction that comes through. It's like that's kind of not the purpose of big data. You're looking for trends. In this case, it's the same kind of thing. You're looking for general things that you're trying to get done. If you can't fire everybody individually with this, then you're going to have to do it the old-fashioned way. The thing that's good about it, though, is what I've found is I transpose words, I mumble words, I say them wrong sometimes. It's when I'm talking, and for the most part, unless it's the key portion of the key phrase in there, as far as the variables go, Alexa just basically figures it out. It's actually pretty good with doing that. If you need exactness, you'll have to put in slots, and you'll have to do a lot of database work to make sure you to try to get that in there with your intents. And then the converse side of that is, what does Alexa say back? Plain text is 100%, or by default is what it does, 100% plain text. So you give it a string and it'll basically say it out. But like I said, if you go fishing for bass, but you play a bass in a band, and you do both those things, then Alexa's not going to know the difference between bass and bass. So for things like that, you would have SSML. So you can give an SSML response back where essentially it will go, use audio voices. You can add breaks in there and paragraphs and pauses like for commas and things like that. Alexa actually does that pretty decently if you put in commas and periods, but you can actually force it to be a little bit longer if you want. You'd have defined alphabets in there. Basically say as, and you can spell it out. So if you wanted to say, my social security number, it'll say 4, blah, 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 blah. You can actually tell it to say the numbers as opposed to trying to say it's 400 million, 300. It's just not that way. So, and then you can also give it, like I said, the bass versus bass thing. So an example of this would be, let's see, I can't remember what the key is for this. Alexa, tell do forward, abort, abort, abort.
5, 4, 3. Abort sequence canceled.
All right, so in this example, I actually put just a SSML instead of doing just a straight text thing. And I put a break of 1 second in between the individual numbers so that it kind of gave that stimulation of it, doing a thing. So you can specify this. It's kind of like HTML just with words type stuff. And then just to throw an example in there of manual phonetics, one of the things I've started to have to do with databases, even if I don't intend for them to be voice activated initially, I usually throw them in here anyway because it's so easy to throw a voice UI over the top of it that if I have them in here and can actually start storing phonetic information in here about the data that I would be searching upon, then it makes it easier to implement that voice interface later. Even if you don't populate it, it's nice. I guess technically you don't have to do it because I can just throw it in there whenever since it's a NoSQL database. But it's just, I can just put it in there, but you have to think about if I'm going to have a voice activation over this particular file or this particular process, what are the things it's going to have problems with as far as either repeating back to me or understanding me saying to it. So it's just another thing to consider. And that would be the phonetics piece up there. An example would be, for those of you who use Couchbase, they have a new SQL language called Nickel. And so this application I have goes out searching for technology search terms. And N1QL, there's no way Alexa would figure out what in the world I was talking about if I didn't tell it specifically. When you read that back to me, don't say no one cool. Just say nickel. So what I'm telling her here is say when you see that phonetic, say nickel. And then varying the response is another nicety to do, which we kind of mentioned before. This is what I've started doing. In this case, I've got an array of responses. So like if you look at the top 5 for this month here in the bottom one next to the bottom one, the top 5 variable gathered this month are variable, 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 variable. In this case, I only have one response. But what I do is I basically call, when I get a certain situation, I say, all right, call this particular Alexa response for this particular question. Sorry.
To ask me a question, just say the wake word, then ask it.
So it'll basically take the variables I have from my application and put them in this template and spit it back to me. And I don't think I have an example up here, but I actually would have multiple array responses for that. And then the randomizer that on the response piece would pick one of the ones in the array and just send it back with the same pieces that it had to fill in. So, and that's what essentially it looks like from the code. I go out and get Alexa markers with the key, ask for help, and it turns it into response, and it does not end this. That should be it. No, actually, it keeps the session open. So if it asks me for a help question, she said, "What do you want to do?" I want her a job, and it just keeps going from there. All right, things to remember. Enunciation helps, but it's not critical to success. I'm kind of proof of that. I mean, the fact that Alexa ever works for me at all is actually pretty cool. Ambient noise, though, is one of those things where it really, really plays havoc with it. So if you've got a lot of stuff going on with you, and you say, "Alexa, do this," if you guys have one, I think it's got 7 microphones in the top, and you can see, based upon the blue ring, let's see if it, Alexa, Alexa, Alexa. See if you probably can't see it from here, but it'll follow, the little light ring will follow me around based upon where the sound's coming from. So if you've got a lot of people around, they're all talking just in their own ways, it'll basically spin. Because it's looking for a good source of input coming through. Also, if you put it into a corner with curved walls, it goes kind of crazy with that too. You should have, you should not have to have, this is misspelling up here, you should not have to have thousands of samples, but you need more than a few. So when you're putting out sample utterances for it, as far as different things are going to fit in your data slots or in your variable slots, give it more than just a handful of things. Give it weird names, long names, short names, whatever the diverse nature of the data is, kind of give it some bounds on those so it has a chance to see what all the different types are. Don't strive for perfection, but don't blow up your ship on a misunderstanding. So you have to make sure that if it's a very, very critical thing, rethink the voice thing if you really want to do it with voice, and then if you do, make sure you have safeguards in there so it does what you want it to do all the time as opposed to more often than not. So if you guys anybody do multilingual type programming, it's the same kind of thing. Using strings for the different words, it's basically treating it the same way, almost like it's a different language. 2 words DevOps. So this is one of those things where you can spin up VMs, you can have it, throw out databases, print reports, run jobs, all sorts of cool things. All you need is just need to have something little thing on the front of your API that handles the voice, and it'll be cool. Be polite. And Alexa doesn't care, Siri doesn't care, Google Now doesn't care. But if you take your applications, you can give the illusion that you care. So if your user happens to say please at the end of their thing, at the end of the response, and you happen to see it, have a spot for just called niceties, a little variable slot for niceties. And if it's filled, then give them a different response that actually includes you're welcome or thank you or something like that. It's just one of those things from a conversational perspective. You help make it not be like I'm talking to a machine anymore. I'm talking to, not really to say a person, but I'm actually having a conversation and I'm having a good interaction with this device. Makes it more fun to deal with too. And it could be a cheap way to get cool tech into the enterprise because you're sneaking it in. It's one of those things where I doubt you'll ever have an application on Alexa or some similar device in your enterprise that becomes mission critical. But it's one of those things where if you come in and do some DevOps stuff with it and it becomes cool and everybody starts using it and you expand it and so forth, then all of a sudden it becomes mission critical. And if you wanted to have, like in my case, Go in your workplace, then all of a sudden now it's like, well, we can't get rid of we've got Go staff, we got people that know this or whatever language you want to do, Phoenix or F# or whatever else you wanted to do. We've got staff that do this. Now it becomes a viable technology to have for other things in your organization too. That's just kind of the sneaking ninja way that I think though. So use that at your own risk. And the last slide I have is if you want, I have Alexa framework in the Go language out on GitHub. If you wanted to grab it, it's out there. It actually works. So it's a quick start way to pull it down and start pumping data through, and it'll parse it for you correctly, and you can start dealing with it. So that's what I have. What kind of questions you guys have? Sir? I haven't tried it, but I would say I can create one of those things in like a minute and a half. So what I would probably do is kill it. I'd make sure I have my utterances file in my my SoundX file, or my file with my variables in it, and then just copy those out and then create a new one, call it the same thing, paste it back in, you're good to go. As long as you keep the same input. But then you have to change your API key to what it's expecting. Yeah. Yeah, that's the only thing I've seen. I haven't seen them say, rekey it. Anybody else? Yes, sir.
Slots come through, when your words come through in slots, how do you know what order they came in? Like the order they were spoken in?
It's a good question because it comes down to the order that you had them in your utterances file. Let's see if I can get through it quickly. So it'll come through in the order you have them in here. So if I say, tell Camp.io to check in Karthik Sankara on this one, that's first name, last name. But I could also have it say last name, first name, based upon, say, tell Camp.io to check in based on last name, this one. So whatever order it fills them in here in your template is the order they're going to come across on your side. So the problem you're going to have, though, is if you key on the order, If they ask it differently, or you put in a different utterance in here that flips them, then you're going to have to account for that in your code. There was a question. Yes, sir.
What's the process right now for submitting a skill to Amazon to get it published?
Good question. I have not done that yet. So it's if I had to guess, it's very similar to the Apple submission for their mobile stuff. There is, you go through, once you have everything done, let's see, I want to say back. Okay, guys, close your eyes real quick. It's going to somewhere you go really fast. I'll try to get back to that screen. There's they have a checklist here on the left. And if you get them all green, then you can actually publish it. You can submit it for publication. So the testing piece is done, then you put your description in, and the publishing information, once you get the HTTPS certificate aligned to your stuff, then it should go in there. I have not gone to that piece yet because I've never turned that green. I haven't needed to yet, but that would be the port right there. And it sounds like a similar process, but not as rigorous as what Apple goes through. It's just one of those things where if your application, depending upon what you do, is also going to have more of a back end to it, because if you have like accounts and that type of thing, that you have to have people register for, then you may have a web presence as well as just the voice presence. The stuff that I do, it's like all internal to either work or home type thing, so I don't have to go out and go through the publish because it's just all for personal use. So, sorry. Anybody else? I think this was $100. The tall one is $179, and they go on sale for like $20 off periodically throughout. So it's not super expensive. I mean, it's not super cheap, but Anybody else? Prague. The question was, can I trigger Alexa by walking into a room? You mean? Just by the fact I show up? No, it's because it's all voice. It's voice activated. The nice thing about it is it's in a room. I can activate it just by talking to it, which is kind of the purpose. It would be nice if it knew I was in the room. So, like for example, I've got 4 in the house, which is completely insane. I've got 1 in the office that I test with, and I've got 1 in the kitchen that we use for various different things. 1 in the living room, and then 1 in the bedroom. And the bedroom one is the one in the corner with the curved walls. And when the alarm goes in the morning, you say, Alexa, set the alarm for 5 a.m. and it starts going off. You can't get through the alarm going through because the sound's bouncing everywhere. It's a real hassle. But we get up, so it's effective. So if it would sense my presence and then say something to me, well, it'd probably scare the crap out of me, number one. But it could be kind of maybe useful for that. But for the most part, it's unobtrusive. So I walk in, it's there. I know it's there. If it's not doing anything, whatever. But if I need something like, hey, Alexa, add this to my shopping list, it'll just do it, and I just go about my way. It would be nice, though, if I was playing music upstairs in the office, and I walked downstairs to the kitchen, and if it would just kind of follow me, that would be cool. But no, currently it does not do that. Yes, sir.
Are you worried about any privacy concerns? Because it's listening all the time, what you're saying all the time, and it's just reacting after you.
Being on Team Iron Man, I really don't care. If I was Team Cap, then I probably would. To be honest with you, I guess I don't really think about it that much, to be honest with you. It's because if it comes out that Amazon's listening to everybody and selling secrets on the black market for it or using it for market, then they're going to be in a world of hurt. So I kind of treat it like Google or even Apple, because when you plug it in, Siri's the same thing. I mean, it's listening all the time. And I think Google now listens all the time anyway. So it's given the fact that in 5-10 years it's going to be so pervasive out there, it's going to be ridiculous. It's not going to matter. So, anybody else? Yes. The question was, can you make it turn on devices? I actually have it hooked up to my Nest thermostat, and I can adjust the Nest thermostat with it. You can turn on the lights. I think you can open garage doors. You can check and see if your garage door is open. Those types of things. The privacy that you mentioned, there was one because you've seen the Bluetooth locks for your front doors, like Schlage and those companies. And if you had one behind your front door, you could just go, Alexa, unlock the door, and it would So you'd have to be careful about stuff like that. But yeah, it does do that, so you have to be mindful of what you really wanted to do. All right, I think we're almost out of time. We got another minute left. Anybody else? Yes, sir.
Along those lines, you have to use the hockey puck and the Alexa to get the commands in there. Is there an app through your phone or something where you can send commands from your phone to a server that uses the API?
The only thing I've seen like that is that dev piece on the Amazon webpage where you can type in words or a command and send it to your device, but it doesn't send it to your device. It just sends it to their process and sends it back to you from their process to say, this is what it would say if it came out of your device. But I can't remotely send something. Well, I take that back. It comes with a remote control that's Bluetooth connected, and you can say Simon says, it'll say whatever. So if you're on the other side of the house, and you could like really scare the crap out of your wife or kids or whatever, because hey, psst, somebody's in the front door, and it'll say that. But there's nothing else that you can do programmatically from like way remote to go over the network to do it. It's kind of a security thing, because otherwise you'd be driving down the neighborhood sending things to people's Echoes all the time, and it would be awesome, but it would be kind of a... Yeah, and in order to get the application on your device, it has to, like some of the new stuff, like the Uber app, for example, you have to register that application with your device. But currently, there is no way to remotely send stuff to it. Anybody else? Awesome. Thank you guys for coming up.